Hello everyone. Let's begin Chapter 2, Measures in Epidemiology. First, let's review the definition of epidemiology. Epidemiology is the study of the distribution and the determinants of health-related states or events in specified population. That is, an important task of epidemiology is to describe the distribution of disease in a group of people. Then, what is distribution of disease, and how to describe the distribution of disease? Distribution of disease is referred to how a disease occurs in a population, such as who developed the disease and where and when does the disease occur. So, distribution of disease means 3W. Who developed the disease in population means distribution by person. When does the disease occur means distribution by time. Where does the disease occur means distribution by place. You can organize and summarize data according to person, time, and place. And then, how to describe the distribution of disease, that is, what measures can be used to describe the distribution of disease. Some descriptive measures can be used to examine the occurrence of disease in a given population. In addition, they may be used for comparing the occurrence of the disease in different populations. There are 4 types of measures which can be used to describe disease in a population or between populations. They are rate, ratio, proportion, and index. Rate will be introduced in this class, and ratio, proportion, and index are on the pages of 22 and 23 of the Epidemiology textbook. You can teach yourselves. A rate is the probability of occurrence of some particular event in a given population. When calculating the rate, the numerator is number of cases or events occurring during a given time period. The denominator is the population at risk during the same time period, and times k-value. K-value may be percent, maybe 1,000 per 1,000, 10,000 per 10,000, and 100,000 per 100,000, etc. Pay attention to the denominator contains the numerator, and the numerator comes from denominator. What's case? Case, an important term in epidemiology, is individual with an event or condition of interest, such as disease, health, effect, cure, death, side effect, or sign or syndrome of a disease. In general, persons who are affected with a disease are referred to as cases. There are 2 types of rate. One is measures for disease occurrence, that is morbidity rate. They can be used to describe the distribution of disease in population. Another is measures for death, that is mortality or survival rates. They can be used to describe the distribution of deaths in population. Lesson 1. Measures for disease occurrence, morbidity rates. There are 4 measures commonly used to describe disease occurrence: incidence rate, prevalence rate, attack rate, and secondary attack rate. First, incidence rate measures the rate of occurrence or frequency of new cases of disease in a given population in a given time. It can be used to express the risk of disease and determine the need for disease control measures in population. Look at the formula of incidence rate. The numerator is the number of new cases, that is, the number of newly affected persons, newly diagnosed, newly found patients during a given time period, usually during 1 year. The denominator is the number of population at risk, that is, the size of the unaffected population under observation, free of disease at the start of observation, all members, during the same time period as that of numerator. K value is proportion base, means how many cases per 100, per 1,000, per 10,000, or per 100,000 in larger population, usually 100,000. This is an example of calculating incidence rate. The numerator is the number of new cases reported. The denominator is the observed number of population. So, incidence rate is the number of new cases divided by the number of population. And the result is 511.18 per 100,000. Prevalence rate is the proportion of the total number of cases, both new and ongoing, of a specific disease in existence in a given population at a certain time. Total number of cases means all cases, including new and old cases. Prevalence measures all cases of disease in a population, both new and ongoing, and is used to describe the burden of disease in a given population and plan the level of health service required in a population. If the time of investigation is very short, or at a specified point in time, that is point prevalence, the numerator of point prevalence is the number of existing cases at a specified point of time, and the denominator is the number of population observed at the same point of time. If the time of investigation is over a specified period of time, that is period prevalence, the number of period prevalence, the numerator of period prevalence is the number of existing cases over a specified period of time, and the denominator is the number of average population observed during the same period of time. So, point prevalence is the proportion of a population that has a disease at a specific point in time, just like single snapshot. Point in time can be a calendar date, such as the 5th August 2015. Or a point in someone's life, such as college graduation. Period prevalence is the proportion of a population that has a disease at any time during a specified period. It measures proportion of population with disease at any time during the time period, such as during the year of 2015. It combines prevalence with incidence, such as survey question: did your child have diarrhea during any of the last 7 days? This is 7 days prevalence. Such as, have you ever in your life had? This is lifetime prevalence. This is an example about cases of a specific disease in a population of 25,000 over a 1-year period. There are 12 patients over a 1-year period. X means an existing patient. DX means a new patient occur. R means recovery. D means death. So, period prevalence over a 1-year period equal to 12 divided by 25,000, and the result is 48 per 10,000. Point prevalence in April 1st equal to 6 divided by 25,000, and the result is 24 per 10,000. In this example, there are 8 new cases over 1 year. Number 2, 5, 6, 8, 9, 10, 11, 12 are all new cases. So incidence rate equal to 8 divided by 25,000. And the result is 32 per 10,000. This is comparative factors affecting prevalence measures. Measures are increased by 1. Immigration of ill cases. 2. Emigration of healthy persons. 3. Immigration of susceptible cases or those with potential of becoming cases. 4. Prolongation of life of cases without cure, that is, increase of duration of disease. 5. Increase in occurrence of new cases, that is, increase in incidence. So, all factors that increase the numerator and decrease the denominator will increase the prevalence. Measures are decreased by 1. Emigration of ill cases. 2. Immigration of healthy persons. 3. Improved cure of cases. 4. Increased case fatality from the disease. 5. Shorter duration of disease. 6. Decrease in occurrence of new cases, that is, decrease in incidence. So, all factors that decrease the numerator and increase the denominator will decrease the prevalence. This is difference between incidence and prevalence. Incidence is new cases occurring during a period of time among a group initially free of disease. And prevalence is all cases accounted on a single survey or examination of a group. Incidence is all susceptible persons present at the beginning of the period. Prevalence is all people examined, including cases and non-cases. Incidence usually duration of the period. Prevalence usually single point. Incidence means rapidity of disease occurrence. Prevalence means percentage of population with disease. Incidence come from cohort study, population-based surveillance of deaths or specific diseases, such as cancer registries. Prevalence rate come from prevalence study or cross-sectional study. This figure shows the relationship between incidence and prevalence. The waterfall is regarded as incidence. The reservoir is regarded as prevalence. When recovery and death of cases are stable, the more incidence, the higher prevalence. If the less incidence, the lower prevalence. Attack rate is a measure of the number of persons affected by the disease outbreak among persons at risk in a limited time period. It is a quantitative measure of the extent of an outbreak, such as foodborne outbreak. The numerator is the number of new cases in a shorter period of time, usually less than 1 month, such as foodborne outbreak. The denominator is the number of persons at risk during the same time as that of the numerator. K-value is usually 100%. So attack rate is a measure of incidence in a limited time period in a specific group, such as foodborne outbreaks, food poisoning, chemical exposures or environmentally related occurrence, such as an influenza epidemic with an attack rate of 10%. Secondary attack rate is a measure of risk that is typically used in infectious disease investigations involving a pathogen with a short incubation period. The numerator of secondary attack rate is the number of cases among contacts or primary cases during the period, also called secondary cases among persons defined as contacts. The denominator is the total number of susceptible contacts, that is, all contacts at risk, exclude primary cases. K-value is usually 100%. So, people in the group who become infected from the original source are referred to as secondary cases, and the total number of persons infected in this way is divided by the total population exposed to the primary resources. Is called the secondary attack rate. The secondary attack rate is often used when cases of illness occur in the same household or workplace as the primary sources. This is an example of secondary attack rate. 7 cases of hepatitis A occurred among 70 children attending a child care center. Each infected child came from a different family. The total number of persons in the 7 affected families was 32. One incubation period later, 5 family members of the 7 infected children also developed hepatitis A. So, secondary attack rate equal to 5 divided by 32 minus 7. The number of secondary cases is 5. The number of contacts is 32 minus 7. The result is 20%. Summary. First, incidence rate measures the rate of occurrence or frequency of new cases of disease in a given population in a given time, and can be used to express the risk of disease in that population. Second, prevalence measures all cases, both new and ongoing, of disease, and is used to describe the burden of disease in a given population. Third, attack rate is actually a measure of incidence in a limited time period in a specific group. Fourth, secondary attack rate is a measure of risk that is typically used in infectious disease investigations involving a pathogen with a short incubation period.